Good afternoon, everybody, and welcome. Thank you so much for joining us in person and for the folks online virtually. I'd like to start by setting the stage first before we get into our topic. Around the world, organizations large and small spend years developing products and technologies, serving their members, their customers, their students, their citizens, and on the way building reputations that allow them to operate. To work well, an organization must have trust, solid infrastructure, skilled people, and increasingly valuable data to help power that innovation. Then in one click, one forgotten line of code, a moment of vulnerability, all of that foundation is at risk. Targeted and untargeted attacks leak intellectual property, unravel years of work, compromise customer trust, and bring operations to a standstill. We've all seen it. The intensity and sophistication of attacks on your infrastructure, our infrastructure, are evolving faster than ever. Every corner of the cloud landscape is targeted, from significant incidents like the WannaCry ransomware attacks to the Midnight Blizzard attacks on Microsoft and the US government. Cybercrime is big business. To put it into perspective and frame what cybercrime has cost the world, last year it added up to be about the third largest GDP of countries. Just incredible. And the headlines are nonstop. You've seen them. We, our competitors, our customers, our partners face this every day. Just 3 weeks ago, Microsoft Security Research published a blog explaining that threat actors from a nation-state group called Storm 940 have been taking advantage of a persistent global compromise of small office and home office routers, creating an unpatched global network of bots, and then use that network to go after on-premises, Azure, Microsoft 365 users with password spray attacks. But they didn't stop there. Their tools automatically scanned, dumped credentials inside environments, and moved laterally within networks. They attempted to access network devices, install proxy tools, remote access Trojans, we call them RATs, for persistence and to maintain that persistence, and then use those same tools to automatically attempt to exfiltrate data in ways that we just hadn't seen before. Their goal was to disrupt and profit from this activity. Now, you'll hear us say over and over at this conference that the cloud is revolutionizing industries, changing how people work and organizations communicate. We expect that cloud services and usage to continue to grow. We're actively investing and growing significantly. We love to show how many new places we're going in the world. We design our cloud infrastructure with security in mind from the ground up. We benefit from a mindset and start from a mindset where we're continually learning, building our collective intelligence, and of course, building advanced tools and infrastructure for that. With thousands of security engineers in our employ, we've also recommitted the company where every single employee must make security their first priority. So we invest heavily in cloud security, coordinating efforts across research, product development, and even public policy to enhance cybersecurity. We're not in it alone. Along with working with you, with our partners, even with our competitors, Microsoft advocates for global standards, things like the Digital Geneva Convention to help protect against cyber attacks by nation states, and we work with governments to help them responsibly handle vulnerabilities. My goal for today is for you to build on our learning and guidance, leverage our models of zero trust, build defense in depth to help your organizations prevent attacks, and give yourselves the grace to learn from our mistakes and the ability to make your own. So with that, I'd introduce myself. My name is Kareem Batish, Vice President of the Trusted Platform team in the Azure Core Engineering Group at Microsoft. And with me is...
Hi, I'm Deepak Bansal. I'm Corporate Vice President and Technical Fellow in the Core Engineering organization. I'm one of the pillar drivers responsible for the network pillar in the SFI.
Thanks, Deepak. In our session today, we're diving deeper into what these emerging threats look like, the protections that we've built into the Azure platform to stand strong against them, and a framework that guides every layer of our security approach. I'd like you to leave with a clear sense of the risks, the tools, and proactive security strategies you can use to protect your own or your customers' cloud environments before an attack has a chance to take hold. Let's jump in. I want to cover a few recent cyber attack examples. And put distributed denial of service attacks up there. These aren't a new thing. However, we see them evolve and become increasingly sophisticated. At this time last year, there was a notable shift in patterns. The holiday season saw a surge of DDoS attacks, and of course, that brought challenges with festive celebrations, people's Black Friday holidays, verges, Singles Day in some places, and posed some incredible challenges to our infrastructure and our customers' infrastructure. What we saw were UDP-based attacks, predominantly, originally targeting gaming workloads, but then shifting to web applications, accounting for about 80% of the attacks. The notable trend that came out last year was the emergence of a malware network called NK Abuse. It leverages blockchain technology, so there isn't a simple or straightforward command and control infrastructure. Really, really hard to detect, hard to trace down, and the patterns changed and evolved. And so shutting down one part of the botnet simply activated another. Really, absolutely fascinating, and done at a fairly low cost to the attackers. We weren't special. Azure's DDoS attack trends reflect global patterns, and the attacks became more politically motivated and targeted, partly, of course, due to ongoing geopolitical tensions. DDoS for hire services, known as stressors or booters, continued to be popular for attackers. They were essentially borrowing or renting out their tools and infrastructure. Azure's own DDoS protection services dynamically adapted. We made many changes, learned lots of things, and those were crucial against defending against these attacks of our customers and for platforms like Office, Microsoft 365, ensuring that there was robust protection. Cloud account takeovers represent another scenario. They've been around again for some time, where password spray attacks would essentially take over an account within an organization within a tenant. But one pattern that we started seeing last year that was different was targeting users by taking over an account and then sharing a document through SharePoint or OneDrive or email or other mechanisms, allowing the delivery of Trojans and other tools to users who go through, navigate those shared links from people they trusted. The attack strategy represents a significant threat because it allows for a more easy traversal of identity takeover and then exploitation of cloud resources than many other schemes. And the way and approach that sharing was done is increasingly sophisticated using technology like AI, ChatGPT, and others to create compelling messages, often seemingly human in the voice of the person who is sending a sharing link. Last and not least are attacks that leverage security misconfiguration. Many different layers, of course, of defense are there. However, we had incidents such as one we call Blue Bleed, where a misconfigured Azure Blob Store exposed sensitive data between Microsoft and our customers, and perhaps most notably, the Storm 558 attack, where unauthorized mail access was done by a state actor, exploiting Microsoft 365 and a series of miscommunications that they were able to stitch together to read the email of senior government officials in the United States. Those nation-state cyber threats are highly sophisticated. They're often involving espionage, sabotage, and attempts to disrupt critical infrastructure. Now, they're typically state-sponsored, although there's for-hire organizations who provide those services. And while they might target government agencies, private sector organizations are often involved because they provide tools and capabilities and services to critical infrastructure and those government agencies. And so the supply chains of any one of these organizations is a potential target that attackers can leverage. We see that again and again. These attacks, they're persistent, they're well-resourced, and they're extremely difficult for any one organization to defend against. The second category I hinted at earlier, which are AI-based attacks. Research by Microsoft and OpenAI has shown that nation-state actors are misusing and weaponizing generative AI tools, including LLMs and tools like ChatGPT, in their cyber operations. AI could be used to craft those personalized, very convincing phishing messages and emails that are very difficult to detect. They can also be used to analyze large data sets to identify the most effective tactics or locations within an enterprise, and then tailor messages or approaches for specific targets. AI is also being used to automate the process of finding and exploiting vulnerabilities in the system. Often, what attackers will do is they'll go and scan huge amounts of things, find a vulnerability, leverage it, and traverse to the next point. With AI, they're more quickly able to collect large amounts of data and jump to that next hop at a much, much lower cost to them. Last, and not least, our supply chain and supply chain attack. All large-scale systems face risks in their supply chain. On the software side, open source components, third-party libraries that are used can contain security flaws or malicious code. Ensuring the integrity and security of these components is critical. Microsoft builds thousands of services. Many of those services include third-party resources and libraries in their final product. At Microsoft, we're focused on protecting our continuous integration and continuous deployment pipelines of our products. We assume breach. Malicious actors target and inject vulnerabilities at every stage of the CI/CD pipelines. So using tools like Azure Pipelines or GitHub, and Deepak will talk a little bit more about other choices that we've made, those help secure build processes and build on Microsoft's own internal practices. Hardware supply chain issues are a little more insidious. They pose threats that you've perhaps seen play out recently in the case of compromised telecommunications equipment in the Middle East. Counterfeit components, tampering during manufacturing, or even in transit, and vulnerabilities unintentionally introduced by suppliers all matter. Microsoft protects against these threats to ensure the reliability and security of our infrastructure throughout its lifecycle. As an example, Azure manages risks associated with third-party suppliers, ensuring that all partners adhere to strict security standards, not just to prevent breaches, but to maintain trust. We do regular assessments and audits of our suppliers in every step of our supply chain, from the moment of design all the way till when the hardware is delivered in our data centers. I'd be remiss if I didn't remind you of the shared responsibility model that we've been publishing and advocating for in our cloud over the last decade and even more. In the on-premises world, the customer owns the entire stack. They're accountable for every aspect of security for applications, for services, for hardware, for the network. When shifting applications to the cloud, those responsibilities become shared between Microsoft, and it really depends on what service type gets used. Software as a service, platform as a service, and infrastructure as a service. At every layer you go down and get closer to the metal, more responsibility ends up on the customer side. With that, we continue to simplify customer responsibility with systems like the one that we announced earlier this week, Windows 365 Link, which makes remote device management of those client endpoints much easier than before, or reduce bad choices that can end up compromising customer environments, like when we require multi-factor auth for accessing Azure resources. But still, customers need to apply these and have the ability to change these configurations for their organizations to be successful. On that note, I'll hand over to Deepak, who'll show you how we approach security of our platform and what we do from a Microsoft point of view.
Yeah. Thank you, Kareem. I guess Kareem has scared everyone enough by now. So let's now talk about how we're protecting the Azure platform itself. As Satya said, security is our #1 priority. And we are taking a comprehensive approach to securing the Azure platform, following the SFI principles of secure by default, secure by design, and secure operations. Here are some of the examples of how we are securing the Microsoft's cloud platform itself. If you look at securing the supply chain, we are doing a lot of investments in ensuring that the supply chain for all the software that we run in Azure is secure. We are leveraging SDL. We are leveraging integrity of code from design all the way to implementation and deployment. We are building tools like Dependabot. This is an amazing tool that we have donated to CNCF. It lets you manage the vulnerabilities in all your dependencies. Another tool that we have built is called Notary. It helps you verify trust for the source code. So we are building these tools that we are leveraging ourselves, and we are making them available to you to use in your own environments. We are also investing heavily in hardware supply chain. We are leveraging root of trust devices such as TPM, as well as Azure Security and Resiliency Architecture, which we are leveraging to ensure that the hardware lifecycle is secured through build and deployment all the way through its lifecycle. If you look at resources, right, resource misconfiguration is a common attack vector that is leveraged by threat actors. And a lot of it has to do with inadequate access controls. In Azure Core Platform, we've eliminated local passwords, local authorization as much as possible, and moved to Entra-based IDs. Entra provides amazing benefits because the password is never accessed by the user, so there is no chances of the password getting leaked. Or if you have to rotate the password, you can rotate the password at the click of a button. So within Microsoft, within Azure, we are on a mission to eliminate all local passwords and move entirely to Entra-based IDs. Where we have a need to keep a secret, we store it in a key vault such that it cannot be compromised by threat actors. We measure the secure score for all of our services and make sure that that secure score does not regress and remain high for each one of our services. Before any service goes to production, it has to meet a minimum secure score bar. Moving on to network and data security, we've made tons of improvement here in securing the Azure platform. Kareem talked about DDoS and the growing threats around DDoS. All our internet-facing endpoints that Microsoft provides to our customers are behind Azure's DDoS protection at this point. It's an amazing technology that has protected Microsoft and our customers from the largest scale attacks and the most complicated attacks that we have seen in the world. We have been on a mission to implement zero trust in the network by implementing network isolation for all of our endpoints using various mechanisms that are available in the platform, such as network security groups, virtual network tags that lets you put ACLs on your firewalls, as well as a new technology called network security perimeter that I'm going to demo and talk a lot more about. We are implementing memory isolation and encryption to protect our workloads, our own 1P workloads that constitute the Azure Cloud Platform itself. On the identity and access management side, again, following the least privilege access principle, we are ensuring that all our employees have just enough and just-in-time access only, right? All our access controls for all our services and all our operational endpoints enforce just enough and just-in-time access. We conduct regular user access reviews, revoking access for any users who do not have any business accessing any of the resources that are part of our cloud platform. And most, if not all of these examples that I talk about here are available to all of you, so you can learn from our experience and implement these mechanisms yourself, because they really help elevate the security posture of the service, of the workload, and lets us sleep well at night, and I hope they'll enable you to sleep well at night, knowing that you have multiple layers of defense for your workload, such that even if one layer of defense was breached, threat actors couldn't compromise your workloads and your platforms. OK, I briefly mentioned Azure Network Security Perimeter. This is an amazing technology that we are announcing in Ignite. What this technology is, securing the PaaS resources has been very painful, right? You have various kinds of PaaS resources, storage accounts, SQL databases, Cosmos DB, key vaults. Typically, all these PaaS resources are exposed to the internet, and you only rely on identity protection to protect these resources. Well, you know what? Identity is the most compromised security mechanism, because social engineering, what may be, threat actors have access to identities of your employees or insider threats. It's really a very significant threat surface that you must mitigate with additional defense mechanisms. So what network security perimeter does, it lets you put all your various PaaS resources inside a perimeter. And then you can specify policies on that perimeter and push those policies to all your PaaS resources with a click of a button. So rather than configuring firewall for each and every storage account and each and every SQL database, you just set the policy, and those policies include inbound access rules as well as outbound access rules. This diagram shows how one VM is authorized to access all your PaaS resources inside the perimeter, and other VM is not allowed. And the way you access network security perimeter is you go to the portal, you create a network security perimeter, and then you select a set of your PaaS resources. So here, I'm selecting a network security perimeter that I've created, and then I'm going to go and select the PaaS, actually, first create a network profile where I will specify inbound and outbound rules. These are as simple rules as, hey, this source IP is permitted to access these PaaS resources, and other source IPs are not permitted to access these PaaS resources. And I select all the PaaS resources, put them in enforced mode, apply. At this point, all those PaaS resources are secured based on the network policy that you specified. I'm going to show how I'm using NSP to secure a key vault. Here I've put a key vault inside my NSP. And in the next screen, you will see how one of the VMs, which is permitted to access that key vault, is able to access the key vault. So let's let it play for a second here. And then I'll show another VM, which was not permitted by my network policy that I applied to the network security perimeter that this key vault is part of. That VM is denied access to the same key vault. So just by a simple click of a button, I'm able to secure all my key vaults. I may have hundreds of key vaults, thousands of storage accounts. In case of Azure platform, we literally had hundreds of thousands and millions of PaaS resources. And going and securing each one of them one at a time would have been unmanageable. We have several other network security announcements that we have made in Ignite, and recently, one such announcement that I'm very excited about is Azure Bastion Developer. Accessing your VMs securely from the internet has been a big challenge for our customers. Typically, they have relied on deploying a Bastion premium SKU, which was more onerous, very powerful. But to simplify the experience, we are giving an always available free Azure Bastion Developer. So essentially, you go to the portal, you click Connect, the Bastion Developer gets deployed in the background, and you just connect to your VM. It's as simple as that. You no longer have any reason to expose any of your VMs to the internet, right? Even if you're a developer, you must never expose any VM to the internet. Just use Azure Developer SKU, because Azure Bastion Developer, because it's always there. It's provisioned for you already. I already talked about network security perimeter. We are also investing significantly in building network skills in the Microsoft Copilot for Azure. These networking skills not only let you plan, design, and troubleshoot your networks, but they also help you secure your networks. Because again, doing security is hard, and we need automation, and we need tooling to do security. And what better tool to use than Copilot? So we are making Copilot skills available that helps you do all that very easily. Similarly, we have enabled firewall skills in Copilot that helps you investigate attacks in the firewall, and it's generally available to all of you as well. Let's move forward. Kareem talked about DDoS protection, and it's a significant threat to all the workloads that are exposed to the internet. Of course, as far as possible, don't expose your workloads to the internet, but then you have to make your services available to customers at large. So for those workloads that are exposed to the internet, DDoS is a feature that you must use. We offer two kinds of DDoS protection. Premium DDoS protection that can be applied at a virtual network level, and an IP protection SKU that can be applied at an individual IP address level. Let's look at a quick demo here for DDoS protection. So here, I go to the Azure portal, and I am able to actually see my virtual network, and I'm able to go to the protected resources and enable DDoS protection on a virtual network. When I enable it on a virtual network, it leverages the DDoS premium SKU, and all the resources inside that virtual network that are exposed to the internet are protected. Alternatively, I can go to my IP address and click on Protect IP Address, and that will give you IP protection for that specific IP address. Again, lowering the bar. If you need to protect the entire virtual network, you can protect the entire virtual network. If you need to protect individual IP addresses, you can protect individual IP addresses. And we have DDoS workbooks that expose extensive telemetry. The demo just passed through. We initiated a DDoS attack. The DDoS workbook shows you telemetry around when the DDoS protection kicks in. And then it also shows you very rich metrics around what was the volume of the attack, what kind of attack it was, and what kind of mitigation was applied to protect against that attack. So really out-of-the-box experience that we are leveraging heavily to protect all of Microsoft's internet-exposed resources, not just within Azure, but across the entire Microsoft suite of services. And the same capability is available to all of you to leverage for your workloads that are deployed in Azure. OK, moving forward, confidential computing is an amazing technology that Microsoft has been leading and building over the last few years. It lets you create a secure environment such that even if the cloud were compromised, your workloads running on our cloud would not get compromised because your workloads are leveraging the hardware that is running on our servers, and the hardware is making sure that your workload is secure. We are very excited to do the gated preview of AMD Genoa-based confidential VMs in many regions. These VMs provide 40% improvement in performance. They support the most advanced security technologies, and they leverage a combination of hardware-based virtualization and Windows hypervisor technologies to secure your workloads that are running on our cloud. In addition, we are also announcing gated preview of a new confidential computing product called Azure Confidential Clean Rooms. So the problem that Azure Confidential Clean Rooms are trying to solve is when there are multiple parties who want to interact, work together on a data, how do you securely share this data among those multiple parties such that no one who is not authorized to access that data is not able to access that data? So Azure Confidential Clean Room creates a safe environment such that only the workloads that are permitted to run in that confidential clean room environment are authorized to run, and they're authorized to access data, and no one else is able to access the data, or no other unauthorized workload is able to run in this clean room. And this is all using verifiable trust, so you have complete confidence that this is protected. OK, another amazing capability that we are announcing at Ignite, and I'm very excited to announce it, is Azure Integrated HSM. HSM is critical to secure your encryption keys. The encryption keys get stored on HSM, and the workload is able to call APIs to the HSM, never accessing the keys in the guest operating system. With Microsoft's new in-house security chip, the integrated HSM chip, which will be deployed in all new Azure servers starting in 2025, you will be able to use this technology on all your workloads. It's integrated into the server on which your workload is running, so the key never leaves the hardware. Your workload is running locally, making the calls, and be able to do cryptographic operation without exposing any of the keys in the guest OS or the host operating system. So the host were to get compromised, or the guest OS were to get compromised, your keys are still secure. And it's designed to meet the highest security standards. So all the certifications, FIPS 143 level 3, all those are met by Azure Integrated HSM. Here is another slide that shows more details on Azure Integrated HSM. What I'm showing here is an HSM service where you upload your keys. Those keys get delivered securely to the integrated HSM chip that is running on the server. The integrated HSM chip is caching those keys. That's the HKVC component over there. And your workload is able to make cryptographic API calls and be able to decrypt data or use the keys in however it wants without the key ever leaving the chip that is shown here. And as I mentioned earlier, it supports the latest encryption technologies, so you can trust that your keys are really, really secure in the cloud platform, no matter what host OS or guest OS vulnerabilities happen to exist. OK, with that, let me hand back to Kareem to bring it all together.
Yeah, thanks for letting me bring it home, Deepak. The well-architected framework is a set of tools, which includes Azure Advisor, as well as a set of guidance and documentation to help organizations run their applications across a set of 5 pillars, one of them being security, of course. What we do know is that not everyone uses it, not everyone runs the tools and looks at them, and frankly, with teams like Deepak's continuing to innovate in security of the platform, providing more options, updating defaults in some cases, it's important to stay in the know and understand your security risk profile and changes that you could make either for applications that are already deployed or as you're planning to build applications. The well-architected framework provides that. The security pillar in the well-architected framework emphasizes design principles and recommendations to get to zero trust principles across your deployment. So this demo, or what I'll show you or play while I chat, is focused on the network controls category. It highlights recommendations to safeguard web apps and services using a web app firewall, which protects against security risks outlined in the Open Worldwide App Security Projects, the OWASP top 10 of most critical risks. For this demo, we're using this app that they build, or that is built by that community group, called the OWASP Juice Shop. It's a sample application that I believe is the opposite of a best practice or template app. It's full of security vulnerabilities. As we get there in just a moment. So looking at this app, you can see it's a simple web application. It has some search capabilities. But before we get going, we'll hit F12 to open up the developer toolbar on the side of the browser. That search function allows us to look up products. In this case, we'll look for a search term banana, hitting enter, search results appear, and you can see the HTTP requests down below. Taking a closer look at that dev toolbar, you can see that the API call was made to the application's REST endpoint, and there was a query param that accepted user input for search queries. Again, you can already see that there's some problems brewing here. After invoking the call, there's a JSON structure that came back. We can go and try to repeat that call in a new browser window to take a look at the content that's getting returned. Now, bots and other applications are automatically doing this against your services all the time. Attackers are continually testing and probing applications in much the same way that we're doing over here. And so I'm not going to go into SQL vulnerabilities and SQL injection, what you could do here. But there's a very simple example highlighted by the sample app where you can inject a SQL statement to the search query and retrieve a different table to reveal a bunch of information. User emails, user email accounts, hashed passwords, a bunch of other sensitive stuff that shouldn't be revealed by the applications. These details can, and we see them happen all the time, get exploited for further attacks, phishing emails, retrieving data, crypto blocking, locking the data. And so it's sort of a general set of problems. Now, it's important to understand that these vulnerabilities exist. These are the kind of mistakes that are commonly made by developers everywhere. And while we do things with GitHub and Copilot to help people build their applications more reliably, the key is to understand that you've got those risks. With the well-architected framework in Azure Advisor, the recommendation is, of course, to deploy a web application firewall. Using Azure Front Door, web app firewall policy, you can configure custom rules or leverage the ones that are set by default out of the box to work here. So what we did in the video in the background here is we enabled, or we are enabling, web app firewall and rerunning the test that we just did before. We made a call with SQL injection, and by simply enabling those policies, the mistakes in the application are blocked by the web app firewall. And so the developer has time to go and fix the series of vulnerabilities that are in the application. Things that we do in those web app firewalls continues to evolve as we learn patterns, we see different kinds of attacks, and continue to mount defenses against them. And so the act of simply enabling the web app firewall gives the grace to developers, IT shops, to make mistakes, to learn, and be protected against the kinds of attacks that are not just increasingly common, but increasingly automated and increasingly intelligent. So there are three things that I would ask for you to do right now that you're not already doing, or you may not already be doing. The first is to get educated. We spend a bunch of time updating our Learn content, providing a bunch of information in things like the Cloud Adoption Framework, which takes the concepts that we've touched on or gone in depth today and plan out a secure by default, a secure by design strategy for your organizations, your applications. The second is to go and review your existing configurations using tools like the Azure Advisor and the different templates like the well-architected framework reviews, be able to go and get a clear profile of risks that your organization, your deployments may be exposed to. And the last thing is to take Deepak's recommendation. If you're using PaaS services, deploy network security perimeters, enable DDoS protection. It's tough for us to do to you by default, because there's a lot of choices there, but it is something that is relatively straightforward to do and apply. The well-architected framework will help you do that, help you make those choices and apply them. And with that, thank you. There are a bunch of other sessions at Ignite around security, a few that have already passed. They're recorded. You're able to see them shortly. And a few of them ahead with folks talking about responsible AI tomorrow, Mark Russinovich, Scott Hanselman. And then a really fantastic discussion about confidential computing and AI and GPUs. And last, looking at security and security ops and how to bring the practices that we have at Microsoft to your organizations. This afternoon, we'll be at the Cloud Migration booth. We have some roundtables as well. It'd be lovely to join you there and talk about anything that you'd like to talk about or concerns around security. And with that, thank you very much. We appreciate you being here and looking forward to seeing you soon. Thank you.